Okay, we'll take a very popular interview question, very frequently asked in the first round or phone screening rounds. So you have been given a tree, let's say something like that. You have to convert this tree into its mirror image. Mirror image. Okay, what kind of image does a mirror create? What is the property of, if you stand in front of a mirror, what does it do to you? Lateral inversion, that is right. Lateral inversion means that if you have a mirror, whatever appears in left, that appears in right, and whatever appears in right, that appears in left. And now this left-right combo is very much in sync with whatever we have learned, because we know that, hey, a tree is composed of a left subtree and a right subtree. So it looks like I have to swap them. It kind of looks like that, right? So if I have a mirror here, of course, this 2 will remain 2, but this 5 thing will come here, and this 3 thing will go there. So basically, the left and the right children are going to get swapped. But this swapping, will it only happen for the children of 2, or will it happen for all the nodes? It'll happen for all the nodes, right? The same thing will happen for 5 also. Its left child was null and right child was 4. So now what will happen is that now the left child will be 4 and the right child will be null. So you can see this 4 is here and this null is there. And for this 3 again, the left and right, which was 6, 7, will be changed to 7, 6. So this is a mirror image of that. The easiest possible code that you can write, all that you have to do is you make a function call to, let's say, R. And when you are at R, you don't have to do anything to this R. You just have to swap R left with R right. And you know how to swap 2 items using a temporary variable. So you can have a temporary variable that swaps these 2 children. And then you have to recursively make a call on the left subtree and right subtree also. You have to make that call. Why? Because you have to perform this swapping for all the nodes, right? So let's say we have a function called as toMirrorImage. toMirrorImage takes node star R, which is root of a subtree, and it is void. It does not return anything. All that it does is it structurally changes the tree. See, whenever you are traversing a tree from top to bottom means when you are at root, you are making call to root left and root right. So you're coming down. So when you're coming down, you will eventually come to null. So when you come to null and then you try to do null arrow right, null arrow left, very bad. So you don't have to do anything when you touch null. So you would say if R is null, don't do anything, just exit, just return. Okay. Otherwise, the first logical step that you want to do is you want to swap the children. And the next logical step that you want to do is you want to go down, or you want to make recursive calls to the left and right. So this first logical step is very easy. You can have a node star temp because you want to swap this with that. So maybe in temp, you can temporarily store R left. And then what you can do is R left equals to R right. And now in this R right, you can accommodate temp. So when you do this sort of thing, what has happened is after just this much offline, the left child of 2 has become 5. So now the situation would be the left child of 2 is 5 and the right child of 2 is 3. But you do not want just this much, you want that much. So it is important to make a call here as well as here. So after this much, you need to do toMirrorImage. You need to make this call for root left and toMirrorImage root right. The responsibility of this call is to convert this into mirror image. The responsibility of this call is to convert this into mirror image. These calls will not tamper whatever you have done above, right? They'll just do their job and everything will be done. So again, classic case of do something at the root and then delegate the calls for left and right.